the decision making from the database side, and also we can see some of MongoDB products that can help us do the DevOps work very easily. Okay, so I'm actually gonna do this talk at MongoDB World 2017 in Chicago. We will be the first to hear it out loud as a public crowd. But if you want, I can get you a discount this event, 40%. If you like going to Chicago this June 2021, so let me know after this presentation. So, as a technical service engineer, we usually encounter complex customer problems, complex customer environments. Most of the time it's in production, but sometimes we get the privilege to actually go and be there on the design board and work with them on how to build their environment. One of these complex questions that sometimes customers have is whether MongoDB can support a multi-master architecture. So I know that usually people think about MongoDB, they think about sharding and replica sets. By the way, just a quick question: does anyone works with MongoDB at the moment? Cool. Like standalone replica sets. Somebody? Okay. Okay. So I'll try to do it from the basics up. But basically, I really want you to understand how can we build a multi-master MongoDB deployment. How can we benefit from it? I want you to learn about zone sharding and about replica sets in complex environments. It's not just a 3-node replica set, but something a bit more complex. And I want to show how Cloud Manager can assist us very easily to deploy such an environment. Because deploying an environment across, let's say, 20 servers once took like a day or two and a few engineers. I'm going to show how I'm going to do it in 10 minutes. Okay? Cool. So what are we talking about? What is a multi-master deployment in my eyes? Okay? So considering the growing demand of high volume, write-heavy applications with a low latency requirements and complex high availability topologies, building the database layer with a multi-master orientation for operational locality is substantial. Some of you or most of you are going, what? And that's intentional. I put this complex sentence here just to show how sometimes as human beings we can look at a complex problem as this huge monolithic block. And I want to show that if we simplify things and really build it block by block like Lego, we can reach our goal state very fast and understand what happens underneath the hood of the system. So let's simplify things. So what do we need? So we need our data access across several data centers. Let's say we have a data center in US East, US West, and Asia Pacific. We want our data to be available on all those regions for two reasons. One is availability of the service, and the second is the data durability in case of a disaster. We want our data to be located in a different geo-region. So we want a multi-master database, but why? So first of all, operational locality, something that Gwen said. We want to write our data locally within our data center, and we want to read it locally. If we can neglect the network latency, we can actually benefit and speed up our application. Data durability, so we want our data to be available on other data centers if we're going to fail over to them. And last thing is we want an active service, and we want it for two reasons. One, we bought infrastructure, we paid for it, whether it's in the cloud or on-premise, we want to use it. We want to actually make use of all of our infrastructure. If you're using like a primary standby service, we will not use the standby. We're only for reading. Second thing is we want to keep our hand on the pulse of our infrastructure. Sometimes we don't know if these servers of the standby can actually compete and actually keep up with the load on our system. So if we can write to all of our data centers, we know that the infrastructure is working. Cool, so who wants multi-master databases? So a lot of global distributed apps. So let's say CDN, which is content delivery networks. We want our users to stream their data closer to them, so they won't go cross DC to get a movie or to reach for their device data or anything like that. Retail and e-commerce, so we want our shipping data and our orders data to be located closer to the user. Usually users will get something from the warehouses in Europe, will need their data to sit in Europe. Okay, social networks. So social networks, usually people that we know, usually most of the time are people that are close to us geographically. So we want our data to sit closer to us. And IoT global platforms, so any devices that actually transmits data, we don't want it to go overseas to insert this data and persist it. So we need a multi-master MongoDB deployment, and we want a single database to be spread across all those regions. So why MongoDB, you're asking me? So this is the benefits that MongoDB provides. Flexible schema. It has a rich language. It has a scale-out and replication concepts and capabilities. So if we want to grow with the data centers as we go, we can do it easily with MongoDB. So how will we do that? So we're going to use 3 MongoDB features. First is zone sharding, and I'm going to tell in 1 minute what is zone sharding. Replica sets, which is basically a group of MongoDBs that are replicating one primary to several secondaries. And we're going to use Cloud Manager automation for the ease of deployment and for the sharding management capabilities, which makes our life very easy. Okay, so what is zone sharding? So if you're familiar with sharded clusters, basically it's an ability to have several primaries within your MongoDB deployment. So a single database can sit on several primaries. If we're going to use zone sharding, which was introduced in MongoDB 3.4 and has its old version that's called tag-aware sharding, we can basically say that shard A is responsible for US East, shard B is responsible for US West, and shard C is responsible for Asia Pacific. This means that we will place a primary on each one of these data centers. With this capability, we can read and write data from this primary simultaneously from a single MongoOS to all of these shards. So one MongoOS can feed all of these primaries at the same time. Replica sets. Okay, so as we said, replica set is an ability to take a primary and replicate it to another secondary. So what we're going to do here is we're going to take this primary and have a replica on US West. We're going to take the US West primary and replicate it to both regions. The same we're going to do to Asia Pacific. So if you look at this picture, we basically have all the set of colors in each data center, which means that we have all the data locally in US East, US West, and Asia Pacific. Since we can read from secondaries and or read from nearest nodes, the data can be accessed locally on each data center.
Can you write secondaries?
You cannot. You cannot.
It's not active.
So it's not an active. Well, you're writing to the primary, but you're reading from a secondary. You can read from a primary. Okay, so let's look. Let's say we have this toolbox, this imaginary Photoshop board, and we want to draw our deployment. So we have a set of tools. As I said, we have a primary shard, secondary shard. We have hidden member that we can add, MongoOS, the config servers, which holds the metadata of the cluster, and we can have priority to our replica server. So as I said, we're going to place a primary on each one of the data centers. So we have US East, US West, and Asia Pacific. Then we're going to build our shard. So our shard is going to be spanned across the DCs. So we have secondary, we have two members in each data center. It's an important point. And basically, we want to have two members inside a single DC. So if a member is failing from time to time, we won't fail over to another DC. So if this primary fails, we're going to fail over to this secondary. And we can do it with priorities. So we can say that the priority of this member is 3. Those two members have the second priority in mind, which makes US West the second option to fail over. And the last two members have a priority of 1. And I added a hidden secondary because I cannot have an even number of members inside a replica set. So I won't have a tie in my elections. So I add a hidden member. This member has 0 votes. It doesn't have. I just use a hidden member just to make it clear what kind of member is it. And if we are left with only one data center, we can easily spin an arbiter here and have this replica set continue working. So an arbiter is just a process that gives votes to the replica set. So we can revive this replica set fast, have this secondary turned into a regular secondary, and we're good to go only with one data center. So we're going to do the same to the second shard, but we're going to say that Asia Pacific is, because it's closer, we're going to make it as the second operational failover. And we're going to do the same for the Asia Pacific. We're going to deploy our config servers. So the config servers also follow, since they are also a replica set in this picture, they're also following the rule of having at least 2 members inside the data center, or when one member is failing, we can actually spin up, and we can actually fail over within DC. We're going to place a local MongoOS on each data center. This way we can access locally to our data. Okay, so this is the shards from the picture before. This is the green shard. This is the red shard. This is the blue shard. And this is the replica set of the config servers. Cloud Manager. So we're going to use Cloud Manager for automation. And automation was introduced to Cloud Manager in 2015. Does anyone use Cloud Manager here? Are you familiar with this product? I know you do. So this product is basically have 3 main capabilities. One is automation. It lets you have an agent on each one of your boxes, reports to a central MongoDB management system, and it can be in cloud server, it can be an on-premise service, it can be even your laptop. And the automation agent basically lets you deploy things on your machines, lets you upgrade them, maintain them, scale them out via the web GUI. Also, it has monitoring capabilities, and it has backup capabilities to back up things to our cloud, and you pay by the amount of data that you consume. So why are we going to use Cloud Manager? So ease of a complex deployment. It also gives visibility into our deployment. It has a sharding management capability, so all these configurations of the zones and the ranges to our collections can be done by this GUI. And also, if we need to perform a scale, we can do it easily because we're already using Cloud Manager. Okay, so I'm going to quickly go over the considerations. So as we said, we're going to place each shard primary inside a specific DC. We're going to make it primary that. How convenient. And we're gonna make it the zone, the primary for this zone. The database must be sharding enabled. We're gonna use sharding. Sorry. The collections are gonna use like a DC field, which is gonna be part of the sharding key, and this will actually let the primaries know, the MongoOS know where to route those calls. Only for writes, not for reads. The config server replica set, since it needs to be spread across those 3 DCs, we're going to use 5 members. And if we have unsharded collections, but we still want them to sit locally, we need to place a dedicated database and have a primary shard configuration for this database to be configured to the local DC. So if we have unsharded collections that we want to keep in US East, we're going to create a US East database and going to place the primary shard of this database as US East, same for the other regions. Okay, I've talked about the replica set considerations, mainly why we need an odd number of voting members, and we need at least 2 members inside each DC. And we have this hidden member to retain this symmetry across all DCs. Okay, so sharding configurations. So let's say we have a users collection. So we're going to have a sharding key named DC and user ID. We're going to tag the shards. We're going to say shard A is US East, shard B is US West, shard C belongs to Asia Pacific. We're going to add a tag range to this users collection, and we're going to say, okay, data center that is named US East 0 until US East 9, just a placeholder for the for data centers to come in US East, is going to reside in the US East primary. It's going to be written to the US East primary, and the same for the US West. For space reasons, I didn't put Asia Pacific, but it has the same configuration for Asia Pacific. So let's see how it works under the hood. Okay, so let's say I have my 2 data centers in this case, just for this picture. I have the US East data center and the US West. I have the application running in US East. So I'm writing it with a write concern of 1. That means that I only want the first primary to react to my write. And I'm reading with read preference nearest. That means that I want a nearest node with the smallest latency to respond and retrieve my data. I can use some capabilities like read concern and max staleness parameter in 3.4 to ensure that my data is consistent, that I'm not reading stale data. If you want, I can elaborate about this later. Okay, so I'm going to write a record. I'm going to write a user ID, which is me at mongodb.com, to DC US East 0. So of course, this can be configurable on the app server somewhere, like a metadata that the app server stores that is sitting in US East. And now the data is being written to the MongoOS. The MongoOS goes to the config server, asks for the data, the metadata, where should I place this document, and writes it to shard A here. We're going to write a record that belongs to US West. The same operation is going to write the record to US West. So it's you at mongodb.com. When we're going to read a record, we're going to go to the MongoOS, go to the config server, retrieve the data, but since we're using a nearest read preference, we're going to read it from this member here, which is the replica of US West. We're going to retrieve the data locally and return it to the user. Okay, so I want to show a quick demo of Cloud Manager and how I'm going to spin this in 10 minutes. So
the working like that. The working like that.
the working like that, yeah. Okay, so I hope you can see it from this resolution. Maybe I need to fix this stuff. So I placed the slide from before, just that we will see the exact plan that we want to deploy. And this is actually my canvas. This is actually Cloud Manager. And I'm going to show that I have all of my servers. So the first line is basically created in US East. The second line of servers is US West, and this line bracket of servers is located in Asia Pacific. So US West is here, and those servers are in Asia Pacific. So it's hard to see here, but it's actually said the prefix of DC0 in machines. This is DC1, this is DC2. I don't know why the resolution got so. So anyway, I'm showing you that it's hard to see here, but they are actually deployed into Amazon regions that reside in different geolocations. They each have an automation agent running on them. So now we can go here and spin up a cluster. So it's as easy as saying new, filling in the cluster name, choosing the version. I'm going to start with deploying it only to machines on DC0. So I'm going to say everything that I deploy now should be deployed to DC0. And I'm going to deploy 3 MongoOSs, as I said. I'm going to deploy 5 config servers. Yeah, and I'm going to give them eligible ports to have on those machines. And I'm gonna config server replica set. I can raise the number of shards here, but I won't do that because I want to deploy each one at a time just so it will be easier. So I'm going to have a 6-member replica set, and I'm going to place the priorities the same way that I've written over here. So this 2 will be 3, this one will be 2, this one will be 1, and the last one will be a hidden member. So since the resolution is not so great, I'm going to move forward a bit. And I want to show you that I can actually hover over these processes and drag and drop them to my servers. And this way I can build this deployment really easily. I'm placing the servers according to my replica sets here. And eventually I will have my data centers span across all 3 DCs. I have 2 machines in each data center. So I'm going to show you a group that this deployment is already deployed in, and it's going to take about 5 minutes to deploy. So I can see that all my machines, I can see that I have a primary in each data center. So I'm also getting metrics coming into this cluster. I have 6 MongoDBs, and I have labels here which says US East, US West, and Asia Pacific. So it's easy to understand which shard belongs to which data center. I have the sharding capabilities, which gave the labels. And in here, I have the ranges. So I've associated Asia Pacific to DC2, DC0 shard to US East. And I have my sharding key here that I've placed here. You can place the name of the collection, the shard key fields. And I have my ranges. So I have the US East, the Asia Pacific from 0 to 9, US East from 0 to 9, and my user ID from min to max. So every user that is written to US East will be stored in US East. Here you can see the metrics that are coming in. I can see metrics on MongoDB, on config servers, queries. I can use a data explorer that exists in Cloud Manager, which is a web UI to access my data. And I wanted to show here that I actually have data that is spread across those 3 data centers. But since the resolution is not that great, I'm going to continue. So to summarize.
Can I ask questions about this demo? Like about Cloud Manager? Or
Yeah. Just the last slide.
Okay.
So we talked about MongoDB Multi-Master architecture, or how we are simulating a multi-master workload. So we have the operation locality, which will improve our performance. We have our data redundancy to have our durability of the data. And we have a cross DC access, which gives us a high availability of this service. We use those MongoDB features. We use zone charting to define our primaries in each zone or in each data center. We use replica sets to replicate the data between the zones. And we use Cloud Manager automation to basically do a UI configuration of dragging and dropping services and processes and monitoring them using sharding capabilities to make it happen.
Are you Cloud?
Okay, we're gonna go from
Are you Cloud Manager automation קיים גם בגוגל Cloud או באמזון או Cloud enough?
אז כל סרבר שאתה תתקין עליו אוטומיישן אייג'נט ותכוון אותו לדבר עם הגרופ שלך ב-Cloud Manager, יכול לעבוד עם Cloud Manager. זאת אומרת, זה יכול להיות הלפטופ שלך, זה יכול להיות סרבר בגוגל קלאוד, כל מה שבטוח בפיירוול לעבוד מול הסרוויס שלנו, יכול לעבוד עם קלאוד.
אבל הסרוויס שלנו הוא
הסרוויס שלנו הוא רץ בדאטה סנטרים שלנו, וחלק מהדברים נמצאים בארצות. ויש לנו את הסרוויס של אטלס, שהוא Database as a Service, שהוא מיועד לנהל לך את הדאטאבייס, להקים לך את הקלאסטר, בעצם המכונות נמצאים אצלנו, אתה הולך לחבר את האפליקציה שלנו, לדבר עם האנד-פוינט שלנו, ויש לנו שם פיצ'ר של VPC Peering, שבעצם אתה יכול לחבר את ה-VPC שלך, את ה-VPC שלנו בקלאוד, ואז לדבר מקומית בדיפלוימנט שלנו. כן.
The actual question was about like the Cloud Manager. It's a hosted service of Mongo, right? I don't install Cloud Manager on my server or something, and it just installs agents. You control the agents, right?
So your responsibility is to install the agent, and then you need to install the agent, and then you can control the environment from the Cloud Manager.
And all the configuration, like best practices of like taking advantage of a specific machine type, should be in Cloud Manager, or I still like in the infrastructure layer should define
So things that we can define
the Linux level.
Yeah, so I mean things that we can define on the process level, we're doing through the service of the agent. It's new limits and stuff like that. But things that are storage or the way you configure your kernel, I don't know.
No, kernel no, but again, storage and attach the disk.
No, it doesn't attach the disk, so it just receives the mount point that you want to read the MongoDB data to, and it will create the DB path to this mount point.
Okay, and the question about the deployment to the architecture, what's the tipping point of actually stop using single node replicas and like in comparison to start sharding things in the capacity of data maybe, or I don't know, because I've heard that you should scale up Mongo as much as possible before you start sharding it.
So sharding requires you to use shard keys. If you don't use the right shard key, you can end up, first skewing your data. So you will have a hot shard, which will do all the work. And the second thing is you can run like scatter-gather queries, which are not shard targeted. If you want to scale out data, so you want to take your data that you want to share. So yeah, so sharding will probably be your solution. But if your data does not need to be shared, so you can work with 2, 3, 4 replica sets.
Like you didn't have a certain capacity of data that you shouldn't hold more in a single node and replica shard.
I had
replica set, sorry.
I had a customer who was working with me who did an interesting thing. Actually, he had a write cache with really, really small data size, but he wanted to have the access locally on the same server. So he wants every application node to have its own, let's say, not replica, but its own primary and the other secondary, so you can read the data not going outside of the server.
So the device has still going to primaries, and the primaries can be, primaries not guaranteed to be local.
They can be on 2 machines. They can be on the same
repeat the
machine.
question? Because
Yeah, okay.
can you repeat the question? Like,
The right option that is not guaranteed to be local, right? In terms of data center, we are using this kind of topologies, right? So it can be, it will be local to one of the shards.
one of the answers.
Maybe you want to ask in Hebrew just so it will be clearer for me? Or
Now,
you see
the
it?
question was, if you have a shard key that is DC, means when you hit the MongoS, do the sharding, and it's writing to the other DC. But the primary of US West in US West.
Yeah.
If you're writing from application in US East, it will write to US West.
If you're placing the DC value of
US West.
US West, yeah, it will understand that it needs to write it to US West.
Yeah, and you will receive it in replica there.
Yeah, and you can read it from a local secondary.
So there is no best practice like Cassandra had somewhere in the past that you should have 200 gigabytes of data on the node and not more, right? Like in Mongo doesn't.
It
No,
depends. In Cassandra, you have many things like the event and the shard. Not the shard, like the row size shouldn't be larger than
Yeah, so basically I saw replica sets like that host terabytes of data.
Yeah.
So it's something that replica set can't handle. But again, if you want to grow dramatically, let's say I'm adding 50% of my users at a single time, it will be hard for replica set to. Yeah. If you're gradually going up, you can understand when is your breaking point when you cannot handle it on a single machine. Because in this case, we want to scale writes, right? Because we want to have multiple PCs doing the write workload, and not have one replica set. Well, we can basically have like a primary here and 2 secondaries here, but then this data center will need to write here.
Always.
Yeah. So with combining sharding and replica sets, we can achieve that the data will reside locally, and we can be writing it locally. Yeah.
It's just slightly off topic, but regarding sharding keys, so what do you, like you said you have to choose the right sharding key, right? So it will be distributed and equal.
In general, like sharding keys, what is the best?
So no, it's not a specific question. So what do you do if you think you chose the right sharding key, but then you discover that like your data is not distributed evenly? So one of your cluster is much bigger than the other?
Well, then the best solution is to reshard. Resharding can be painful sometimes, depends on your amount of data. You can always, dump and restore it to a new definition. I guess this will be the best solution, or to migrate data to a new collection gradually. Every time I'm reading an old version collection, an old version document, I'm going to convert it to a new version document, and so on. You're going to slowly change your data model, because that's why data modeling design is very important. So first of all, we have an office here in Tel Aviv, And if anyone is interested in our services or understand how can they engage MongoDB or they want to try out our products or just say hi, we're more than welcome.
Just say hi works.
Yeah.